circle the degree in the numerator and circle the degree in the denominator. When the degree in the numerator is 1 greater than the degree in the denominator, we will have what is called a slant asymptote. There will be no horizontal asymptote there, but there will be a slant asymptote. A slant is that diagonal. It may also be known as an oblique asymptote. So there's no horizontal. So I'm going to put HA for horizontal, and I'm going to cross it out. There is none. Now, we're going to get back to the slant asymptote in just a little bit. Circle the bottom, please. We can determine the vertical asymptote by taking the denominator, if it has a variable. We set it equal to 0, and we solve. So x equals 2 is the equation of the vertical asymptote. Please go on your graph, on your paper, or on the desk, whatever you are using, go over to 1 and make a dotted line. Now we need to figure out what is the slant asymptote. So we're going to put this into polynomial long division. The top goes into the division box, and on the outside is going to be the denominator. And again, if you're new to polynomial long division, it may be helpful for you to make these little dotted lines. So we see 3 columns. This column only contains x squared, x's, and constants. Underline the first and underline the first. And for most of you here in this classroom, I think we can just verbalize this. X times what quantity is x squared? X. I distribute to get x squared. I distribute to get a negative 2x. And then I change the signs. Change and change. So these two are additive inverses. They cancel out. This was a negative 2. What's a negative 2 and a positive 2? A 0x. Bring down the negative 3. X times what is 0x? X times what is 0x? 0. Multiply to get 0x. Multiply to get 0. Change signs. Well, zeros can't change signs. And when you add down, you end up with negative 3. And you may be thinking, like, what do I do with this remainder? In terms of polynomial long division, as it connects to slant asymptotes, just cross it out. We don't care about the remainder. What we're going to do is we're going to write down the equation y equals x plus 0. This is my slant asymptote. Now, if you're confused how to do this, think back to 8th and 9th grade. This says start at 0 and make a dot. And then I'm going to use this slope in order for me to construct the graph. Go up 1 and over 1. Go up 1 and over 1. Up 1 and over 1. And this is a dotted line. All right, the next thing we are going to determine is is there an x-intercept that exists? So you have to be really good at factoring right now. In fact, the first thing I would do probably after I identify what the degrees are, so I know if there is a slant asymptote. Again, whenever there's a slant asymptote, there's no horizontal asymptote. I want to factor this. What multiplies to equal negative 3 and combines to equal negative 2? Is it factorable? What are the numbers? Negative 3 and 1. Now, when the leading coefficient is a 1, we can be super lazy. So I'm going to rewrite this in factoring. X minus 3 and x plus 1 over x minus 2. And why am I doing that? Because now, if you draw a little arrow here, these are going to share with us. When we set this quantity equal to 0, we will determine what is one of the x-intercepts. When I set this quantity equal to 0, I will determine another x-intercept. So I'm going to add 3 to the other side. One x-intercept is 3. 1, 2, 3. Another x-intercept is negative 1. Here's another x-intercept. Okay, so I've done my x-intercepts. Now, how do we easily figure out the y-intercept? The y-intercept. Okay, the y-intercept is whenever x is 0. So let's just come up here. If I come up here and think about this, if I plug in 0, I get 0 and 0. I plug in here, I get 0. I end up with negative 3 over negative 2. Well, negative 3 over negative 2 would be a positive 3 halves, or that's equivalent to 1.5. So go up to 1.5. And now when we draw this is enough appropriate places for me. Remember we talked about yesterday about asymptotes in class? It's going to get closer and closer to your asymptotes. So this is one line. If I could find a color that stands out, that may be helpful. If you have a bad marker, feel free to throw it away. So here is one part of it, and here's the other. It's going to grab those 2 points, and it's going to keep going up.